Hello class, welcome to our second lesson dealing with applications of radian measure. We talked a little bit about arc length, S equals r theta the other day, and today we're going to be looking at another formula with circles that deals with areas. So we'll look at that. Remember the key for all arc length and area of circle questions is that theta has to be in radians in order to find the answer. So the first question is what's known as the gears problem. You should expect this to show up, so you want to make sure that you understand kind of what you're looking at. Most questions will give you both the radii of the big and small gears. Obviously, my gears don't have the teeth that are supposed to be there, so how they interact with each other. But hopefully it gets the point across that there should be a bigger wheel that moves slowly, and the smaller wheel should move faster, and as they interact, that's kind of what you're looking at. So for S equals r theta, they tell you that the smaller wheel moves 80 degrees. So in this corner up here, I said S equals r theta, and that's 2.7 for the radius, times theta, but it's 80 degrees, so I have to multiply by pi over 180. Now, one way you could solve this is you just find that answer. Just find S, okay? And once you find that answer, you're going to plug it into the other equation, okay, for S, because even though one's a longer circle and the other's shorter, they both travel the same distance. It would kind of be like if I told you to go out to the 400-meter track and run a mile versus go into the indoor track and run a mile. You still are running a mile, it's just you're running it differently and one's moving faster around. One has more laps because you're going, each lap is a little bit shorter. So you could do that, plug in S to the other equation and solve. The other option is you could set r theta equal to r theta, and I tend to go that route because I know their S values are the same, so I just set r theta of this one equal to r theta of the other one. And here's what's really cool about this question is that the pi over 180s essentially cancel each other out. So even though you're supposed to have everything in radians, you can kind of get away with it here and say, oh, by the way, it's 26.34 by taking 2.8 times 80 and then dividing by 8.2. So that might be a faster route. Just set r theta of the big equal to r theta of the small, and then divide out the missing piece to figure out what's left. That's my suggestion when you get to gear-style questions. Okay, next question deals with the pulley system. So the idea of a pulley kind of on the pulley system with the rope. So the rope is going around the edge of a circle. So that's why it's in this section. How much rope is needed is an S equals r theta because S is the distance around the edge. Okay, and it's just radius times the degrees. I would work on this idea, right? Make sure you know how to plug in the degrees minutes into your homework and into your calculator. And then don't forget the times pi over 180 here because the formula requires you to be in radians. Next one, what is the angle that it must rotate 10 inches? So we know S and R this time. We divide out, we get 0.8. Remember that's 0.8 radians, not 0.8 degrees. If you think about it, 0.8 degrees is barely anything. You got to multiply by 180 over pi when you work backwards. And then you'll find that answer by taking the 45 degrees, 84 minutes, and then switch it to degrees, minutes, seconds using the DMS feature on your calculator. Okay, the next question that we're going to look at deals with what's known as an area of a circle. The area formula here, which is A equals 1/2 r squared theta. R is still the radius, theta has to be in radians. This is actually the general formula from pi r squared. And the reason that pi r squared works is because 1/2 times r squared times 2 theta all the way around the circle, the 1/2 and 2 will cancel. And so you've been doing this all along with an area of a full circle. And a sector of a circle is like a piece of the pie, essentially. So you're just finding an area of part of the circle as opposed to the whole circle. So I just have a list of questions where you know 2 of the 3 pieces and solve for the missing spot. I will say that more of these questions will have answers like this one where it's in terms of pi. And so this one here, area equals 1/2, radius is 7 squared, and then times pi over 2. And you get this answer. You'll notice that there's no units here, but it would be units squared if you were looking for it because it's an area question. If you had to find a decimal, you'd multiply by the pi and find the answer. In this case, you don't really have to because if they ask you to leave it in terms of pi or as a rational expression, then it would be written as 49 pi over 4. Next one gives you the area. And probably a giveaway that the answer needs to be in something that looks in terms of pi as if pi is involved somehow in the original information. So 12 pi is the area, equals 1/2 times 4 squared for the radius, times theta. 4 squared is 16, divided by 2 is 8. So you're just going to divide by 8 on both sides, and then that's 12 pi over 8. Don't forget to simplify, though, and that's 3 pi over 2. Those of you that are kind of catching something here, notice that 3 pi over 2 is 270 degrees, because it's pi over 2 is 90 times 3 is 270. So my picture is really inaccurate. I should have had my line go straight down from the center, kind of like at the 270 mark going this way. That could happen with some of your questions, that they may not be drawn to scale, so just keep track of that. If you had to get into degrees instead of radians, times 180 divided by pi. Next question gives you an area. Notice it's a decimal, so you're probably looking decimal answers at the end. It's possible you might be doing degrees, minutes, seconds in this question because they say find degrees. So this question should be set up the same way as the last one. Area equals 1/2 times the radius, which is 8 squared. 8 squared is 64, divided by 2 is 32. Divide by 32 on both sides, you get 27.2 over 32. That'll equal 0.85. The problem is that's radians and you want degrees, so you have to multiply by 180 and divide by pi in order to find that answer. And then don't forget, if they ask you to make degrees, minutes, seconds, okay, you have to make sure you use the DMS feature on your calculator to find that. This is a two-part question. They're giving you the arc length and they're saying find the area. So you have to use the S equals R theta formula. 8 pi equals R theta, which is 5 theta, divided by 5. You probably want to leave things in terms of pi in these questions if they have pi originally, as I mentioned before. So 8 pi over 5 is theta. You plug that in here, and a lot of times really nice stuff will start happening, and a lot of things cancel. 5 squared is 25 divided by 5. They cancel and simplify. 8 and 2 simplify, and you'll eventually be left with 20 pi as the area of the sector. But it's a two-part question, so you have to use the S equals R theta equation to find something, and then plug that into the other one, and then solve for that piece. So when you're looking at an area question based upon an arc length, this is the strategy that you want to use. Okay, just a little bit of review of exact values and plug it into your calculator. Cotangent of 4 pi, remember pi is 180, so 4 times 180, or it's 2 pi's, or 2 360s is 720. 720 is just 2 times around the circle. So 1 time around would be here, 2 times around is the same here. And that can be found by using 1, 0. Tangent would be opposite over adjacent, or y over x, which is 1 over 0. And when you flip that, cotangent then would be undefined. Remember, quadrantial angles for tangent, cotangent are typically 0 or undefined because of where the 0 is located. So keep track of that as you're looking at those questions. Sine of negative pi over 6 is going to be negative 1/2 because pi over 6 is a 30-degree angle. It's going downward because it's in quadrant 4 and it's a negative angle. So sine of 30 should be 1/2, but it's negative because it's in quadrant 4. So just some things to keep in mind about exact values. Remember, all exact values are always 30s, 60s, 45s, or 90-degree angles as a reference for what you need in this class. Okay, the next question is find all the answers from 0 to 360. You'll notice that I made a point to say that there were 2 answers here. That's important when you look at these questions. Remember, your calculator can help you find one, but you have to know how to find the other one. Okay, so if sine of x equals some number, you do sine inverse. The inverse operation of sine is sine inverse. So sine to the negative 1 of 0.65. You'll get 40.54. Now that's one of the answers because it's in quadrant 1. The other spot where sine is positive is quadrant 2. And with this reference angle of 40.54, I do 180 minus 40.54, and I get 139.46. Remember, if you have to change to degrees, minutes, seconds, you need to do that on your calculator. And anytime you find an angle, okay, using your calculator, it should be sine to the negative 1 or sine inverse in order to find that answer. Okay, that's everything for today's lesson. We have kind of one more day of application dealing with radian measurement. We'll look at that the next class period. Have a good day, everybody.